Hello dear students, good morning.
Good morning, sir.
Back to the chemistry class. G.O.C. part 1, 2, 3 we have completed and remaining part 4 and 5. So today we'll start the part 4, that is purification techniques. Purification techniques. So what is the meaning of purification? Can you define the word purification, which means yes, separation of impurities from pure substance. If two or more components are mixed together, we need to separate it. That is called purification. And if in this part, so we are going to deal about some different types or different techniques of purifications. So from the heading part of purification techniques. Purification of organic compound. Purification of organic compounds. Purification of organic compounds. Purification of organic compounds. Yes, some common techniques which we are going to use to purify organic compounds are purification, the process of separation of pure sample from impure component, or impurity from mixture, or the different component. Purification means what? Purification means the process of removing the impurity from the given mixture. If pure and two or more components are mixed together, we are separating one component from another. That is called purification. And preferably, we are going to use following methods for the purifications. So just note down the headings. So most of the organic compounds are purified by following methods. The organic compounds are purified by following methods. Number 1, filtration. First one is filtration. Second one, filtration. Crystallization. Filtration, crystallization. Sublimation. Distillation. In the distillation, simple distillation, fractional distillation, steam distillation, distillation under reduced pressure. 4 types in distillation. First one is simple distillation method. Simple distillation, fractional distillation, steam distillation, distillation under reduced pressure. Distillation under reduced pressure. Distillation. Differential extraction and chromatography technique. Differential extractions and chromatography techniques. So most of the organic compounds are purified by these methods. So let us see one by one. Filtration. How the organic compounds are purified by using the filtration. Already you have used the filtration techniques in your day-to-day life. Can you give one example where you have used the filtration? Yes. Tea, coffee. Coffee filtration what is it? Coffee. Water, filtration of water. Okay. Can you explain the procedure? Yes, Sama. Explain the procedure of filtration. First, simple. What is the main principle involved in the filtration technique? Suppose, for example, sugar and salt are mixed together. I have taken sugar and salt and it is mixed together. How you are going to separate? By filtration? Huh? By filtration, is it possible or not? No. Why? So that is the principle involved in the filtration technique is one of the component which must be soluble and one component is insoluble. So soluble component can be separated from insoluble component by using filtration technique. If both the component, both pure and impure samples are soluble in water, then we cannot separate by using the filtration because both impurity as well as pure compounds are present in the solutions. So we pass us through the filter paper which we are going to use to separate the component. So note on the heading. First one, filtration definition. Filtration. First one, first heading, filtration. Definition. Its definition: the process of separating the insoluble solid. The process of separating the insoluble component or insoluble solid. The process of separating an insoluble component of the mixture. The process of separating the insoluble component of the mixture from the soluble component. The process of separating the insoluble component of the mixture from the soluble component in a given liquid, in a given solvent, full stop, is called filtration. The main principle involved in this filtration is principle. So insoluble component can be separated from soluble component. Just one line. So what is the principle involved in the filtration? Insoluble component can be separated from soluble component. That's the principle involved in the filtration is insoluble component can be separated from soluble component. Now look at the procedure. How we are going to separate an insoluble component. I understand. The funnel. Beaker. This is the filter paper. We are using the glass rod. The solution is poured. The mixture. First, the given compound is dissolved in a suitable solvent, in which the only one component is going to dissolve. First, in a beaker, by using a suitable solvent, I have mixed the given compound, mixture of substance, in which only one component is going to soluble in that solvent and one more remains same as it is, insoluble. So this mixture or this solution is slowly added to the filter paper or a funnel in which the filter paper is placed and it is attached with the iron stand. Now, slowly the one soluble component passes through the filter paper and it is separated, whereas the insoluble component which remains on the filter paper as it is. So this is we called residue. So insoluble component can be separated from soluble component. Insoluble component can be separated from soluble component. If both the components are soluble, then both are passes through the filter paper, so we cannot separate. So the main principle involved is insoluble component can be separated from soluble component. If both are soluble, we are going to use some other different methods. So first step, prepare the solution. So once I have prepared a solution, that is given component is mixed in a suitable solvent in which only one component is soluble, and this solution is slowly added to the filter paper or with a funnel. So which contain in which filter paper is placed. So soluble component is passed through the filter paper and it is collected in the beaker. And insoluble component which remains in the filter paper, this is called a residue. This is the procedure. Filtrations. Write down filtrations. A given impure mixture is dissolved in procedure. First step. A given impure mixture is dissolved in. A given impure mixture is dissolved in a suitable solvent. It is impure mixture. First term, it is dissolved in a suitable solvent in which only one component dissolves. The given impure mixture is dissolved in a suitable solvent in which only one component is dissolves. Full stop at continue. Next time, what occurs? After that, yes, I have dissolved, and then it is slowly allowed to fall on the filter paper placed in a funnel. Yes, and continue. Full stop and continue. It is then slowly allowed to fall. It is then slowly allowed to fall on the filter paper, which is placed in the funnel. It is then slowly allowed to fall on the filter paper, which is placed in the funnel. Full stop. What happens now? Yes, filter paper. Yes, the insoluble component remains on the filter paper, whereas soluble component which passes through the filter paper. Yes, right on the same. The liquid containing soluble component, the filter paper, then insoluble component. The soluble component passes through the and insoluble component retained on the filter paper. Soluble component passes through the filter paper, whereas insoluble component retained on the filter paper. In bracket you can write it is called residue. It is called residue. It's insoluble component. This is called residue. Insoluble component is known as residue. Yes, it is separated. Now, rate of filtration can be increased. The rate of filtration, the process of filtration can be accelerated by some different techniques. So here first, if ordinary filter paper is used, the same filter paper, if you are using flattened filter paper, normal filter paper is flattened, means folded filter paper if it is used, then the surface area is little more, then the rate of filtration becomes fast. Flattened filter paper, see normal close smooth surface, it is flattened, means it is folded, and then it is used, then the rate of reactions become fast. The filtration process increases. And the second one, by using Buckner funnel. Buckner funnel means by using suction pump, we can increase the rate of filtration. So in rate of filtration, what happens? If vacuum is created, then definitely the process of filtration increases. We can note 2 points. The rate of filtration can be increased by the rate of filtration can be increased by the rate of filtration can be increased by using flattened filter paper, flattened filter paper, and second one is by using Buckner funnel. D.U.C. Buckner funnel. Here is D.U.C. In this case, vacuum is created, therefore the rate of filtration becomes increased. This is the first one, filtration. Filtration. Second one is crystallization. The second one is crystallization. Number 2, crystallization. Crystal plus ionization, crystallization, which means the process of formation of a crystal in the solution. The process of formation of crystal is called as crystallization. So it is a reverse of a dissolution process. If once the component is dissolved in the solution and in which the crystals are produced, formation of crystals in the solutions is called as crystallization. So here, crystallization and recrystallization, to check the purity, we are going to use the recrystallization. Recrystallization. Here some number of steps involved in this process. Normal in crystallization process, first again we need to use the filtration. The first step, prepare the solution and then filter it. Filtration. So after filtration, we need to separate the pure component and then again recrystallization we need to do. Crystallization, the process of formation of an insoluble solid in the solution is called as precipitate. So here within the solution, if some solids are produced, the process is called as crystallization. So here, in order to get the crystals, the solutions, first you need to prepare the solution. So here, while preparing the solutions, you should particularly concentrate on the choice of solvent. Which type of solvent we need to take and what is the conditions. So our part will concentrate on the second heading, crystallization. Crystallization, process of formation of crystals. Definition, the process of formation of crystal. The process of formation of crystals in the solution. The process of formation of crystals in the solution is known as crystallization. Stop principle involved in the crystallization process is first, the difference in the solubilities of pure compound and impurities. The difference in the solubilities of compounds and impurities in a suitable solvent. The difference in the solubilities of pure compound and impurities in a suitable solvent. See, if the solubility of compound and impurities both are same, if the solubilities of the pure compound and impure compounds are same, then what happens? Both are present in the solution or both are get precipitated. So if there is a difference in its solubility, so one component should be more soluble than other in a particular given solvent or suitable solvent. Suppose if water is taken as a solvent if salt and benzoic acid. Benzoic acid is slightly less soluble, whereas normal salt is readily soluble in water. So if the difference in their solubility, then such compounds can be easily separated by crystallization. So first step, we need to prepare the solution. While preparing the solution, choice of solvent is very important. So which type of solvent is to be taken? So first, it should be inert with the chemical compound. The solvent used in the crystallization method, it should not react with the component. It is inert. Inert means react agvarga. It should be inert, number one. Number two, second condition, the solvent must be highly volatile. That means it should have very low boiling point. It should be highly volatile component. And number three, in that solvent, the solubility of the component must be varies. It must be different. So these are the necessary conditions for a solvent which is using in the crystallization. So choice of solvent is first important conditions for this method. Second, we are going to prepare the solution. Yes, solution is prepared. Suppose if sparingly salts are present, that means it is partially insoluble. In that case, while preparing the solution, heat the solutions. So at hot condition, the compounds are soluble. First, all the components will be soluble at a particularly slightly higher temperature. When temperature slowly decreases, the crystallization process begins. For example, suppose you have taken two components A and B, both A and B. Mixture. One is pure component and other one is impure. Now, if these two are readily soluble in water, can it separate? Because it's readily soluble. So therefore, it cannot be separated from the solution. It cannot form crystals. Crystallization is not possible. So if it is soluble at hot conditions, so first, suppose A is readily soluble, B is insoluble. Completely it is insoluble. Then what happens? We can separate by using filtration technique. So if it is heated, first we need to heat. So as a result, A is readily soluble at higher temperature. At high temperature, the component B is dissolved. It is soluble at high temperature. Now, once the solution is dissolved, after that you just filtrate. Because if any insoluble impurities are present in this mixture, that is to be separated by using filtration techniques. A, B, along with this, some other impurities are there. If it is present, then first you dissolve the given component at high temperature, and then suppose it is insoluble in water, then use organic solvents. So first dissolve the content and then filtration. So upon filtration, one component, the soluble component is separated, and insoluble impurities, if any present, it is separated in the first step. Now you take the filtrate. Upon filtration, thus we are getting some solution. So that filtrate is concentrated. Concentrated means either by heating, so water content, liquid content is minimized. So as a result, it becomes highly concentrated. When it is cooled, when temperature is falls down, automatically the component which is less soluble in that solvent is get crystals which is precipitated. Means formation of crystal takes place. So one component which forms its crystals. So therefore further it is one more time we can filtrate. So first step, impurities are removed, and then second, crystals are produced. It is filtered, washed with water, particular solvent, dried and weighed. So crystallization. Given compound first dissolve. If any impurities, so remember the component must be soluble slightly at higher temperature than room temperature. Room temperature kintu jasti temperature karana. If it is soluble at room temperature itself, then crystallization process is very difficult. It cannot take place. So therefore, the component must be soluble slightly at higher temperature so that the crystallization becomes fast. Note on the principle of procedure. The impure sample is dissolved. The impure sample is dissolved in a suitable solvent. The impure sample is dissolved in a suitable solvent in which the impure sample is dissolved in a suitable solvent in which it is sparingly soluble at room temperature. The given compound or the impure sample is dissolved in a suitable solvent in which it is sparingly soluble, that means partially soluble at room temperature but soluble at high temperature. First condition, it should be soluble at higher temperature. Yes. The impure sample is dissolved in a suitable solvent in which it is partially soluble at room temperature or sparingly soluble at room temperature. Sparingly soluble at room temperature but completely soluble at high temperature. Soluble at high temperature. Full stop. The solution is separated first. It is we are going to make saturated. First solution is a compound is dissolved in a suitable solvent and make it saturated. Saturated means saturated material by heating. So the solution is saturated by heating. Full stop and continue. The solution is saturated. Saturated means saturated solution. Yes. Solvent concentration is less and solute concentration is more. The solution is saturated by heating and then solution is saturated by heating and then allowed to cool Stop. When the crystals of pure substance is formed, upon cooling, the pure substance crystals are produced in the solution. When crystals of pure substance is formed, the solution is saturated by heating and then allowed to cool. We'll stop and continue. When crystals of pure substance is formed, it is filtered. Full stop. The filtrate contains impurities is separated. The filtrate contains impurity is separated. This is the crystallization. If you want to crystallization method, benzoic acid. Benzoic acid. So benzoic acid can be crystallized with the help of water. Benzoic acid is partially or sparingly soluble in water. So it is completely soluble in hot condition. Hot water it is soluble. So once we need to dissolve in a suitable solvent and then the solution is concentrated by heating. If any impurities are present, it remains insoluble. So upon filtration, the impurities are removed and the pure compound or the pure component is going to precipitate in the solutions. Or the crystals are produced and which is separated. Simple word, it is filtered. Filter means it is separated. And after filtration, so the filtrate obtained in the beaker which containing impurities or dissolved component is separated. So first in a beaker, the given component in a given solvent, the component A plus B, one is pure compound and other one is impure. It is dissolved at high temperature. Remember the solvent must be inert. And highly volatile compound means low boiling point. When it is dissolved at high temperature and allowed to cool. Upon cooling, what happens? The component, see, one more condition, these two, pure and impure compound must be differ in their solubilities. Must be differ in their solubilities. The impurities are more soluble than pure component. So therefore, the impure compound is dissolved at room temperature itself, whereas the pure component, its solubility is less. So upon cooling, it gets crystals are produced. So crystals of pure components are produced upon cooling. So this is filtered. So filter. So upon filtrations, so impure sample are separated from pure. So crystals here form again crystals produced. These are pure, and impurities are get separated. It is discarded. Impurities are separated. Filtration. So here some important points, some conditions you can know. The main steps involved in this process. Steps involved in the crystallization. Steps involved. Steps involved in this process. Number one, first one, choice of solvent. Choice of solvent. In bracket you can write, it should not react chemically. It should not react chemically. That is inert. It should be inert. Means it should not react chemically. Number two, it should dissolve more solute on heating. It should dissolve more solute on heating. Number two, it should dissolve more solute. First one, it should chemically inert, or it should not react chemically. First choice of solvent, chemically react alcohol, and it should dissolve more solute on heating. Number two, preparation of solution. Preparation of solution. Next, filtration. Preparation of solution and filtration. Next step, crystallization. Crystallization. Come on, next. Again, one more time, filtration. Next, drying. Removal of color, etc. Crystallization, filtration, drying, removal of color, etc. Full stop. Side heading. Recrystallization. Recrystallization. Crystallization, recrystallization. Here recrystallization. Same process is repeated one more time. First, crystallization is carried. So crystals are filtered. So further, these crystals are one more time we need to dissolve in the same solvent, and then one more time crystallization takes place and filtered, dried, remove the color, etc. One more time purification, a repeated method. That is called recrystallization. The process of crystallization is repeated by taking the crystals. That is a recrystallization. Fractional crystallization means fractional, a repeated process. The separation of different components by repeated crystallization. Fractional, step by step, one by time. Two or more times the process is repeated. Fractional crystallization. First time the filtration, but crystallization, and then filter. We are getting the pure component. I don't know it is 100% pure or not. One more time by taking this pure component, again do the crystallization process by taking fresh solvent. So that is called recrystallization. If again it is repeated two or more times, then it is called fractional crystallization. Crystallization, recrystallization means again it is repeated. If a number of times the crystallization process is repeated, that is called fractional crystallization. So editing fractional crystallization. Just word. Recrystallization. The process of crystallization is repeated again. The crystallization process is repeated, then it is called recrystallization. Ever heard it? Yes, the process of crystallization is repeated, then it is called a recrystallization. Next one, put a star and write the process of separation of different component. The process of separation of different components by repeated crystallization. The process of separation of different components by repeated crystallization. Is known as fractional crystallization. Fractional crystallization. This third one, sublimation. Crystallization, filtration. Similar to next one is sublimation. Can you define the term? What is meant by sublimation process? Sublimation. The process of conversion of solid to gas directly without converting it to the liquid state is called as sublimation. So here, if two components are given, a mixture of two components, can you separate these two by sublimation? So what is the conditions required for that? Yes, one of the components should be sublimable. That means it is directly converted to gaseous state. Then only we can separate by using sublimation. So the main principle involved in this technique is sublimable component can be separated from non-sublimable component. So in the mixture, one component and other one is impurities. Among these two, one of the components should be sublimable, either pure compound or impure compound. ಎರಡು ಮಿಕ್ಸರ್ದಲ್ಲಿ ಯಾವುದೋ ಒಂದು sublimable ಇರಬೇಕು. Upon heating, the sublimable compounds are converted into gas and it is get separated. Either it may be pure or impure. So sublimable component can be separated from non-sublimable component. Sublimation definition, principle involved, procedure. Take the mixture in a watch glass, cover it with a glass funnel closed by cotton or glass wool, and then heat. In class 10, maybe you have performed a watch glass. The impure sample is taken in the watch glass and then it is heated. In a Bunsen plate, it is heated. This is covered with a funnel. It is covered with a funnel and this is closed with glass funnel. When it is heated, so from this sample, only sublimable component is get converted into gaseous phase. So sublimable component is converted into the gaseous phase. As the concentration increases, it gets solidified again. So this is the solids. So either pure or impure, sublimable component which is get separated from the mixture and is which can be purified, separated from non-sublimable component. When the mixture is heated, the sublimable component which gets converted into the gaseous phase, and then impure compound is remains on the watch glass as it is. So therefore these two can be separated. The main principle involved is sublimable component and non-sublimable component. Yes, heading sublimation definition. Write down its definition. The process which involves the direct conversion of a solid into the gaseous state. Process which involves the direct conversion of a solid into the gaseous state on heating. without passing through the liquid state. The process which involves the direct conversion of solid into gaseous state on heating without passing through the liquid state is known as sublimation. Full stop. Principle. The sublimable component can be separated from non-sublimable impurities. The sublimable component can be separated from non-sublimable component. The sublimable component can be separated from non-sublimable component. Procedure. Yes, procedure. The impure sample is taken on the wash glass or china dish. It is covered by placing a funnel inverted cotton or glassware. When it is heated, sublimable components get separated from non-sublimable components. That's not the procedure. The impure sample is taken. The impure sample is taken in the china dish. The impure sample is taken in the china dish or simply wash glass. The china dish. The impure sample is taken in the china dish, which is covered by placing a funnel inverted on it and the stem of a funnel is closed with cotton. And the stem of funnel is closed with a little cotton. Full stop. When it is heated, the volatile component is raised up. When it is heated, the volatile component is raised up and condensed at the cooler part of funnel. When it is heated, the volatile component is raised up and condensed at the cooler part of funnel. Part of the funnel. Examples. Yes. When it is heated, the volatile component is raised up and condensed at the cooler part of funnel. Stop. Example: camphor, naphthalene, etc. Camphor, naphthalene, benzoic acid, etc. Yes. The fourth one is distillation. Distillation, differential extraction, and chromatography techniques. We'll continue in the next class.